Hello students, welcome to another session of differential equations. In this session, we will be dealing with homogeneous differential equations. So what kind of equations are called homogeneous differential equations? So before moving on to that, you must know what do you mean by homogeneous function. Here, a function f of xy is said to be homogeneous function of degree n if it can be expressed in the form. Okay, so any function of xy is said to be homogeneous function of degree n if it can be expressed in this form. ಯಾವೆಲ್ಲ ಫಂಕ್ಷನ್ಸ್ ಅನ್ನ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಅಥವಾ ಈ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯನೋ ಅಂತಹ ಫಂಕ್ಷನ್ಸ್ ಅನ್ನ ನಾವು ಹೋಮೋಜಿನಿಯಸ್ ಫಂಕ್ಷನ್ಸ್ ಆಫ್ ಡಿಗ್ರಿ n ಅಂತ ಕರಿತೀವಿ. Okay, so let's understand with the help of an example. Illond example is, say f of xy is equal to, I am taking one small example, x square plus y square. So illi ನೀವು either take x highest degree term outside or y. Okay, so highest degree is x square here. 2 is the degree of this expression. So I can take x square common. Even you can take y square also. If I take x square common, what you will get? 1 plus y square by x square. Okay, look at this now. This is expressed in the form x square, and this, look at this. This is a function of y by x. Every term is in the form of y by x. I can show you. You can express it as x square into y. 1 means y by x power 0. And y by x whole square, I can write it as. Look at this. So each term is in the form of y by x. So I can write this expression by some function of, this can be written as g of y by x. So this is your g of y by x. Okay, so now look at this. F of xy is expressed. How f of xy is expressed? X power n into g of y by x. Here n is 2. So this implies f of xy is a homogeneous function of degree 2. Okay, so similarly here, suppose your f of xy is, say x cube plus y cube plus 3x square y. Okay, so here degree of each term, here make correction, x cube, this is y cube. Okay, so degree of each term is 3 here. 3 and 2 plus 1, 3. Now we can take either x cube common or y cube common. So now see here, if I take y cube as common, now what you will get here? You will get x cube by y cube 1 plus 3. If you take y cube common means divide each term by y cube in the bracket. So you will get 3x square by y square. Okay, now see here, this is in the form, look at this, this is, each term is in the form of x by y. So I can write it as, okay, so this bracket as a function of x by y. Now see here, this function f of xy is expressed in the form y power n f of x by y. So this implies f of xy is a homogeneous function of degree 3. Okay, so any function which can be expressed, look at this, any function which can be expressed in this form, x power n f of y by x or g power n y power n g of x by y. So such functions are called homogeneous functions of degree n. N can be any positive or it can be 0 integer. Okay, so now let us understand what do you mean by homogeneous differential equation. Okay, now see here, homogeneous differential equation means what? Homogeneous differential equation, a differential equation of the form, dy by dx is equals to f of xy is said to be homogeneous if f of xy is a homogeneous function of degree 0. Okay, f of xy must be homogeneous function of degree 0. Okay, so if dy by dx is equal to f of xy and f of xy is a homogeneous function of degree 0, then such differential equations are called homogeneous differential equations. So let me give an example. See here, suppose dy by dx is equals to x square plus y square by 2xy. Okay, now see here, this is your f of xy. Now whether this is homogeneous function of degree 0 or not, you have to check. Okay, so here clearly see here, if I take x square common in the numerator, okay, so what will get? 1 plus y square by x square. Here degree is 2. If I write like this, x square into 2y by x. Okay, this can be written in this form. If you multiply x square into x cancels. Okay, so what will get? X square cancels, means x power 0 will get, and this is your this full term I can write g of y by x or f of y by x, whatever you can write, g of y by x. Okay, now see here, this is expressed in this form, means degree of this is a homogeneous function of degree 0. So therefore this differential equation is homogeneous differential equation. Very easily it can be identified if it is given in terms of powers of x and y. Degree of each term used to be same. See here, degree of this term is 2, this degree of this term is 2, and total degree of this term is 2. Okay, if it is given in terms of exponentials or logarithmic or trigonometric functions, then you will find each term is in the form of y by x or x by y. Okay, so this has to be remembered. So at this moment, this is homogeneous differential equations. Okay, so now you have to think how it can be solved. Okay, so you cannot separate the variables in such cases very easily. So now let's understand how to solve homogeneous differential equations. Okay, now working procedure for solving homogeneous differential equations of the form dy by dx equal to f of y by x. Okay, so see here, in this case dy by dx is expressed as, how it can be it was expressed as g of y by x or f of y by x. Okay, so any differential equation which is homogeneous in nature, how it can be solved? So you have to follow the working procedure. So if the differential equation is expressed in this form, okay, so step 1 is you have to follow these steps. Step 1, put y by x is equals to v. That means y is equal to vx. You have to make this substitution if the given differential equation is expressed in this form, f of y by x. Step 2 is differentiate this. Okay. So differentiate, I can call it as, this is your one equation and this is your two. This is given differential equation and this is your substitution. Differentiate 2 with respect to x, means from this you have to find dy by dx. So what we will get, dy by dx is equal to product rule. Okay, v derivative of x is 1 plus x into dv by dx. Okay, so with this substitution you obtain the value of dy by dx and substitute this in 1. Substitute in place of dy by dx, you have to replace this as v plus x dv by dx. So this is step 3. Substitute 3 in 1. So what you will get? You will get v plus x dv by dx. Okay, here you have to substitute dy by dx as v plus x dv by dx, and f of y by x, you have y by x means v. Now step 4 is separate the variables. Okay, you need to separate v and x term and integrate, you will get the general solution. Okay. Separating the variables, and integrating. Okay, so this is the basic steps you have to remember. So later on you will come to know. So first you have to show that it is homogeneous of degree 0, then substitute y is equal to vx depending on the nature of the equation. Suppose you have to make one note. If your differential equation is in this form, suppose if dx by dy is equal to, if dx by dy is equal to homogeneous differential equation in this form, say g of x by y. If you could able to express it in the form dx by dy is equal to g of x by y, then you have to remember to solve such differential equations, put x by y is equal to v, that is x is equals to vy, and differentiate this with respect to y. Okay, so what we will get? dx by dy is equal to product rule, v into derivative of y with respect to y is 1, y into dv by dy. Okay, so it's exactly the reverse of the previous one. So just variables are changed here and you have to follow the same procedure. You will understand better if you do 1 or 2 examples. So let's move on to example first. So here is the first example of exercise 9.5. Show that the given differential equation is homogeneous and solve it. Look at this. Looking at the differential equation, very easily it can be identified. Look at this. Degree of this is 2 and x into y means 1 plus 1, 2, 2, 2. Okay, so degree of each term used to be same if it is in terms of in powers of x and y. In such case, first you need to express it in the form of dy by dx. Okay, so bring dx this side and transfer this side. X square plus y square by x square plus xy. Now look at this. If you take x square common in the numerator, what will get? 1 plus y square by x square divided by, again take highest degree term x square common, 1 plus y by x you will get. Okay, so look at this, x square cancels, means x power 0 you will get. So you will get x power 0, no need to write, but I'm telling you it's a homogeneous function of degree 0, and remaining I can write it as some function of y by x or x by, doesn't matter, whatever you write. This entire function I am writing as a function of y by x. Okay, so dy by dx is expressed in this form, x power 0 into f of y by x. So what does it imply? So this means given is a homogeneous differential equation, given is homogeneous differential equation, and which is expressed in the form of f of y by x. So now we have to solve by suitable substitution. Okay, so what we need to put now? Put y by x is equals to v. So this implies y is equals to v x. As I said earlier, you have to find the value of dy by dx. Differentiate with respect to x. So dy by dx is equals to, differentiate, v plus derivative of x is 1, so x into dv by dx. So you have to substitute this in either in this equation or here. Okay, so I can call it as 1. So 1 becomes, okay, what one is dy by dx. So dy by dx means it is v plus x dv by dx. Okay, let me write that what one we have. One is this, dy by dx is equals to x square plus y square divided by x square plus xy. Okay, so this is your, yes, x square plus xy. So in this you have to substitute. X means x square as it is, y square means v square x square, because y is equal to vx. Here x square plus x into vx. Okay, y is vx. Simple. V plus x dv by dx. Now x square common you will get, 1 plus v square. Similarly in the denominator, x into x square we have, so x square common, 1 plus v you will get. Okay, always x square cancels. This implies v plus x dv by dx equals to 1 plus v square by 1 plus v. Now try to separate the variables. So first you have to bring this v this side. This is a common procedure for almost all problems. So 1 plus v square by 1 plus v, bring this v this side, that's minus v. So take LCM. So dv by dx equals to 1 plus v square. Okay, bring this v into 1, that is v minus v square by 1 plus v. Okay, multiplying this to this side, so you'll get this. Let's look at this. V square cancels. So you will left with x into dv by dx equals 1 minus v by 1 plus v. Okay. Now you need to separate the variables. So separating variables means v term one side and x term one side. So what will get? You will get one plus, this comes in the numerator, so 1 plus v by 1 minus v, so you'll get 1 plus v by 1 minus v into dv, on the other side dx by x. Okay, let me show you. This comes up and this comes down. What it will be? It will be 1 plus v by 1 minus v into dv. Okay, this goes up, this comes down, and dx goes up, x comes down. This is what separating variables, and that we have here. Now need to integrate. Once the variable gets separated, integrating on both sides. So this is 1 plus v by 1 minus v dv equals to integration of dx by x. So you must be good at integration to find the general solution, otherwise you can stuck. Okay. Now how to evaluate this is the question. Okay. You can do it like this. One thing is you can divide 1 plus v by 1 minus v, otherwise you can make some arrangement. I can write it as 1 by 1 minus v as a one term, and other is v by 1 minus v dv. On the other side, integration of dx by x is log x plus c. Okay. So now you need to integrate this. Integration of 1 by 1 minus v is, it's a log of 1 minus v by minus 1. I will tell you why it is. And this I can keep as it is. V by 1 minus v dv equals to log x plus c. This can be written as minus of log of 1 minus v. Why it is minus 1 means coefficient of v is minus 1, and you know this integration of 1 by ax plus b with respect to x is log of ax plus b by a, coefficient of x. You are right. Here coefficient of e is minus 1, so that's you have to divide it by minus 1. Now here in the second term, so v by 1 minus v, I make some arrangement so as to get this term in the numerator. So what I do is I can write this plus v as, I can write this as minus of minus v by 1 minus v dv equals to log x plus c. Okay, so just to convert the numerator as denominator, it's a minus log of 1 minus v minus, now I can add and subtract 1 in the numerator. So 1 minus v minus 1 divided by 1 minus v dv equals to log x plus c. I have added and subtracted. This is minus log of 1 minus v minus, now you can 1 minus v by 1 minus v minus 1 by 1 minus dv equals to log x plus c. Okay. This is equals to minus log of 1 minus v, integration of 1 minus v by 1 minus v is 1 minus 1 by 1 minus v dv equals to log x plus c. Now you can integrate minus log of 1 minus v, integration of 1 with respect to v is v, minus integration of this is as earlier, again we get log of 1 minus v by minus 1 equals to log x plus c. So that gives you minus of log 1 minus v, open the bracket, minus v, minus into minus plus, plus into minus, minus log of 1 minus v equals to log x plus c. Okay. Now there are two log terms. You can write it as minus 2 log 1 minus v equals to log x plus c. Further, if you want, you can write it as v equals to log of x plus 2 log of 1 minus v plus c. V is equal to log x plus 2 log can be written as 1 minus v square plus c. Now you have to replace y as v as y by x. So y by x is equals to log x. I can write log m plus log n as log mn. Simultaneously I can write 1 minus y by x whole square plus c. Okay, I had replaced y as v as y by x. So this is your final result, or you can transfer x this side. So this is the general solution of the given differential equation. Okay, so there is alternate way for integration, how quickly you do. I have made it very simple and understandable. Okay, so let's have another example to solve. So here is another example. Show that the given differential equation is homogeneous and solve it. Okay. Look at this. Y dash means you can write it as a dy by dx is equals to x plus y by x. Okay. Now clearly see here degree of each term is same. 1, 1, 1. Clearly it is homogeneous. Better you show, you are asked to show. So in the numerator, if you take x common, you will get 1 plus y by x, and in the denominator x as it is. Okay. So what will get? X cancels, means x power 0 into what will get? 1 plus y by x. Okay. So you got it as a function of y by x. Look at this. Dy by dx is expressed in this form, means it is a homogeneous. This function is a homogeneous function of degree 0. So that implies given is a homogeneous differential equation. Okay. Now you have to solve this by suitable substitution. Okay. Now put your dy by dx expressed is in this form, f of y by x. So you have to put y by x is equals to v. That means y is equal to vx differentiate with respect to x to obtain the value of dy by dx. So dy by dx is equals to v, derivative of x is 1, x into dv by dx. Okay, so you have to put this in 1. So 1 becomes, okay, what is equation 1? You have dy by dx is equals to x plus y by xy you have there. Let me substitute. Dy by dx means you have to substitute this, okay, in place of this. So it is v plus x dv by dx equals to x as it is, y means vx divided by x into vx. Oh. Sorry, what we had there? X square x plus y by x. To make correction, I had just x here. So it is x as it is. So v plus x dv by dx, x common, 1 plus v by x. X cancels. So v plus x dv by dx equals to 1 plus v. Now bring this v this side, or you can directly cancel that. Okay, so if you bring v this side, minus v becomes, it get cancels. So you left with 1. Now you have to separate the variables. So I can write it as dv is equal to dx by x. This is what we call as separating variables. Separating variables. Okay. So once the variable gets separated, integrate. Integrating, integration of dv is equal to integration of dx by x. Integration of dv is b. Integration of dx by x is log x plus constant c. Now v is, you have to replace as y by x is equals to log x plus c. So this is the general solution of the given differential equation. So let's have another example. Show that the given differential equation is homogeneous and solve it. Again, see here, looking at the degree of each term, 1, 1, 1, 1. So it is homogeneous differential equation. So this can be expressed as, first you have to express it as x minus y dy is equal to x plus y ds. You can transfer this side. Okay. So dy by dx is equals to x plus y by x minus y. Okay. So now look at this. If you take x common in the numerator, you will get 1 plus y by x You are asked to show it is homogeneous. Highest degree is 1, so you take x common. 1 minus y by x. So you will get x cancel, means x power 0 you will get, and remaining I can write as, look at this. This full term is function of y by x. Every term is in the form of y by x. So given dy by dx is expressed in this form. Okay. So I can call this as 1. So given is, this implies given is homogeneous differential equation. Now as earlier, make substitution y by x as b. Okay, and substitute here. Now put y by x is equals to v, that as y is equal to vx. Okay. The rest of the thing, differentiate with respect to x. You will get dy by dx is equals to v plus x into dv by dx. Okay, differentiate with respect to x. Okay, put this in 1. So 1 becomes what I had. Your 1 is this. Dy by dx is equals to x plus y by x minus y. Let me check it. Yes, x plus y by x minus y. In this you have to substitute. Your dy by dx means this. So v plus x dv by dx equals to, x means x as it is, y means vx divided by x minus vx. So after this, take x common, means 1 plus v you will get. In the denominator x common, 1 minus. Okay, so x cancels. Now we have to try to separate the variables. V plus x into dv by dx, it is 1 plus v by 1 minus v. Separate the variables. First transfer v this side. Okay. So bring this v this side, minus v you will get. Take LCM. So it is v into 1v, minus of minus plus v divided by 1 minus v. So it v square will get. So v cancels. 1 plus v square by 1 minus v will get. Okay. Now we need to separate the variable. Okay. So I can write as 1 minus v by 1 plus v square dv. I will bring this side and this down. dv. On the other side, dx by x. Integrate. Integrating, what we will get? 1 minus v by 1 plus v square dv integration of 1 minus v by 1 plus v square dv, and on the other side you have dx by x. So now integrating. So how good you are at integration is depends. I can write 1 by 1 plus v square as one term minus v by 1 plus v square as second term dv. On the other side it is log x plus. Now look at this. This is clear. 1 by 1 plus v square, its integration is tan inverse of v. So if I write it as tan inverse v directly, now the question is, what is the integration of this? Okay. One can write directly by practice. Now as I said, if numerator is the derivative of denominator, if numerator, this is the denominator of denominator, you can directly write its integration is log of the denominator. So I can make it some arrangement. Its derivative is 2v. So I can multiply and divide it by 2. Okay. So multiply and divide it by 2 so as to make the numerator of the derivative of denominator. So now you can write directly, it is tan inverse of v minus 1 by 2, integration of this is log of 1 plus v square equals to log of x plus c. Okay. Now you can write it as tan inverse of, that is 2 tan inverse of v minus log of 1 plus v square equals to 2 log x plus 2c. Okay, I have multiplied by 2. 2 is common in the denominator for log. So I have multiplied by 2 to cancel this. This implies 2 tan inverse v I can write y by x minus, or I can transfer this side. You can write it as a log of 1 plus v means y by x. So y square by x square plus 2 log x can be written as log of x square plus 2c. Okay, m log n is log m power n. So now we can write log m plus log n as log mn. So I can write it as log of 1 plus y square by x square into x square plus 2c. Remember, log m plus log n is log mn. So if you take LCM, I can write it as x square plus y square by x square into x square plus 2c. X square cancels. So your general solution will be 2 tan inverse of y by x equals to log of x square plus y square plus 2c. Okay. So in this way you can find the general solution. If you do number of examples, you will get an idea. Okay. Let's have another example. Okay, this. Show that the given differential equation is homogeneous and solve it. X square minus y square dx plus 2xy dy equal to 0. So clearly look at the degree of each term is 2. 2, 2 and 1 plus 1, 2. Okay. So let me express it in the form 2xy dy is equal to minus of x square minus y square dx. This implies dy by dx is equals to, okay, I can bring this side and 2xy this side. Minus x square minus y square can be written as, I can take minus inside, so it becomes y square minus x square divided by 2xy. Okay, to avoid getting minus outside. Now if I take x square common in the numerator, what will get? Y square by x square minus 1. Here also, product, what is the degree of this term? Is 2. So I can write it as x square 2 into y by x. Look at this. After simplification, you have to get this only. So look at this. You will get x power 0. And look at this. This is a function of y by x. So dy by dx is expressed in this form. So this implies given is a homogeneous differential equation. As earlier, you have to substitute, and I can call it as 1. So put y by x is equals to v, which implies y equal to vx, differentiate with respect to x. Pause the video, please try yourself. Dy by dx is equals to v plus x dv by dx, as I explained earlier by product rule. Okay, substitute in this equation, y square minus x square by 2xy. Okay, so 1 becomes, what is your 1? Your 1 is this. Your 1 is equation this. Let me take some water. Okay, so what we'll get? V plus x dv by dx is equals to y square means v square x square. Okay, because y is vx, x square as it is, divided by 2x into y is vx. Okay, so this gives you v plus x dv by dx equals to, if you take x square common, so that x square cancels with this x square. Okay, so here x into x, x square. So this x square cancels with this x square. So you're left with v square minus 1 by 2v. Remember this. Okay, separating the variables. First, v transfer this side, x dv by dx is equals to v square minus 1 by 2v, and this v this side minus v. X dv by dx is equals to v square minus 1, transfer this side, we take LCM, that is equal to 2v square by 2v. This is x dv by dx equals to v square minus 2v square is minus v square. So I can write minus 1 minus v square by 2v. You may write minus taking common. 1 plus v square by 2v x dv by dx. Separating the variables, you bring 2v this side and 1 plus v square down. Dx up, x down. This is called separating variables. Separating variables. Once the variable gets separated, integrate. Integrating on both sides. So here it is v square. Okay. So integrate on both sides. What will get? You will get integration of 2v by 1 plus v square dv minus integration of dx by x. Okay, so this. As you know, if numerator is the derivative of denominator, if its derivative is here, you can keep directly log of denominator. So I can keep it as log of denominator, that is 1 plus v square. It is minus log x plus. I said in the beginning, if all the terms are in terms of log, better you can keep constant also in terms of log. This I can write it as, it is log m minus log n, so it is log m by n. So I can write c by x, log m minus log n. So both sides you have log. So taking anti-log, log get cancelled. 1 minus v square is equal to c by x. Finally, you can replace v as y by x. So it is y square by x square is equal to c by x. If you want further, take LCM. X square plus y square by x square equal to c by x. So you may write it as x square plus y square is equal to 1x cancels, 1x comes here. So you will get cx. Okay. So one of the x cancels and 1x remains, you transfer this side. So this is your general solution of the differential equation.